let's get to series and sequences. Sequences and series. All right. So first of all, where's my pen, bro? A sequence. A sequence is just a succession of terms. And we actually have a sequence question in our CSEC maths paper. I think it's the number 5. That's where you're given the table and all of them kind of thing, right? So notice I have a sequence here. For example, this is a sequence 2n plus 1. And so this sequence, when n is 1, the sequence is going to go 3, 5, 7, 9, go on and so forth. So you can see that you have the terms of the sequence, and the nth term, whether it's the first term, second, third, fourth, and this is the sequence itself. Right? Notice generally for a sequence, the first term, second term, you can't have a negative 1th term. You can't have a negative second term. So, you know, your n is generally a positive integer. You can have a 0 term, but generally we start at 1, right? And yeah, give me a done it for this first bit here. Everybody understands what a sequence is. It's just a succession of terms and numbers. That's it. No need to over explain it. Now notice how a sequence is shown by a to the subscript n. Yeah, and these are the terms in the sequence: the first term, the second term, the third term, the fourth term. This here is the nth term. And simple little question here: the nth term of a sequence is given by this. Evaluate a1. I'll do this real fast for me now. A1 is gonna be what? The first term was when n is 1, so it's gonna be 2 to the 1 minus 5, which is 2 minus 5, which is negative 3. So the first term in this sequence is negative 3. A3 is what? 2 to the power of 3 minus 5. So 2 2s are 4 2s are 8. That is 8 minus 5, which is positive 3. And C, we have A6, which is 2 to the power of 6 minus 5. 2 2s are 4 2s are 8, 2s are 16, 2s are 32, 2s are 64. Minus 5 is 59. Consider this sequence here. Right? We have negative 5, negative 3, negative 1, 1, 3, 5. And this is the CSEC math level, right? So in CSEC maths, you are supposed to be able to recognize that if you take negative 5 and you add 2, you'll get negative 3. When you add 2 again, you'll get negative 1. You add 2 again, you'll get 1. You add 2 again, you'll get 3, So the common difference, there's a common difference from one term to the other. And in this case, the common difference is plus 2. So if we was to generalize this, right, where n is 1, n is 2, n is 3, n is 4, and n is n, right? Remember, a will be the first term, right? And we had the first term. The first term plus the common difference will give us the second term. So that is why the second term is the first term plus the common difference. And if you take that and add the common difference again, you'll get the third term. And if you take that and add the common difference again, you'll get the fourth term. And if you add, just keep going. Notice the common difference. Notice this number in front, the common difference. is usually 1 less than n. And so we have the general. Now you could use this in your CSEC maths to solve that question 5, if you want. Right? If you want to solve it real fast, this is the general formula for finding the nth term of any sequence, right? When there is a common difference, and common difference has to do with addition and subtraction, right? When there is a common difference, the series is an arithmetic series. It's also called an arithmetic progression, or an AP for short, right? So this one here is sequences finding the nth term. And so for an arithmetic progression, if you want to find the nth term, or even the formula for the nth term, you could use this expression here, or this equation here. And this equation will spit out the formula and the nth term. This formula will give you anything you want. Now consider this other sequence. Right? I have -4, I have 8, I have -16, I have 32, I have -64. Of course, ... means it keeps going. Notice there's no ... on this side, so -4 is literally the first term. Notice there is a common ratio now. We call it a different one because this one has to do with multiplying or dividing. And well, we don't ever really deal with dividing, we just deal with multiplying by a fraction, you know? But you can see that -4 times -2 will give me the next term. Times -2 again will give me the next term. Times -2 again will give me the next term. So on and so forth. And so if we were to generalize this situation, right, for this sequence, a to the n, well, not a to the n, a subscript n, that is equal to the first term, which is a. Notice the second term, all right? The second term here is when you take the first term and you multiply it by your common ratio. And then you'll have to multiply the common ratio again to get the third term. And you have to multiply the common ratio again to get the fourth term. And this is a kind of way of thinking that you all kind of have to get used to recognizing these patterns, especially when we reach down to the end. And so, of course, we do have this formula here to find the nth term. Notice there is a common ratio because we are using multiply and divide now. It's not addition and subtraction. It's multiply and divide now. So things kind of, change a little bit. And so when we're talking about multiplication and division, it's not arithmetic anymore. It's geometric. So we have a geometric sequence or a geometric progression, which is a GP. So APs, this have a common difference, and GPs, this have a common ratio. For a geometric progression, the formula to find not just the nth term, but also to find the actual sequence, the actual formula, the rule for the sequence itself. A subscript n is equal to A, which is the first term, multiplied by r to the n minus 1, right? Common ratio. Now notice in this situation, the common ratio cannot be 1, because then you'll have ar to the 1 minus 1, which is ar to the 0, which is just a multiplied by 1. You're never going to get a sequence there. So, of course, we do have a couple of questions here. And we'll do a couple of them, and then you'll have the rest for homework, right? Finding the nth term. So we have to, number 1, determine the formula for the nth term. And number 2, hence for each, find the 5th term and the 20th term. So we're gonna do number 1, and we're gonna do A and D, right? So for part A, I have this sequence here: 2, 5, 8. Can we recognize any kind of common difference or common ratio?
Yeah.
Plus 3, right? So if we plus 3, so that means we're dealing with a common difference, D. We're not dealing with R. We're dealing with D, right? So because we're dealing with a common difference, I know that the first term is 2 and the common difference is plus 3. So therefore, this is an arithmetic progression, an AP. What is the formula for AP?
A plus open brackets n minus 1 close brackets by D.
Thank you very much. Ethan, you're sleeping?
Yes, sir. I'm alive.
Ethan, do you want this class to go till 12 o'clock?
I don't mind.
You're the wrong person to ask. Shanisha, do you want this class to go till 12 o'clock?
I also wouldn't mind.
All right. Jed, you're already worse. Okay. I don't
We'll
want,
see. Just a really good teacher. That's all.
I don't want this
Yeah.
class to go till 12 o'clock. Well, let's see. Let's hope so, right? So, all right. So this is the formula here. The first thing I had to do is determine the formula for the nth term for this particular sequence. So therefore, a to the n is going to be the first term, which is 2, plus n minus 1 times the 3. So therefore, the formula for part 1 will be 2 plus 3 into n minus 1. This is the formula, right? For part 2, we want the fifth term, which is A5. So that will be 2 plus 3 into 5 minus 1. Somebody tell me what that is. And then we want the 20th term, which is 2 plus 3 to the 20 minus 1. Somebody tell me what that is.
This is 59.
Thank you. So imagine for the number 5 in your CSEC maths. Because remember, in CSEC maths, you're given that number 5, which is the sequence question. But what they do is they give you the sequence, and you have to use an investigative process to come up with this. They never teach you in CSEC math, they never taught you this formula. So you could use this formula to just figure out that number 5 real fast. So number D, I have 2, 6, 18, ... Is there a common difference or a common ratio that you could recognize?
Times 3?
Yes, it's very easy. Multiply by 3. 2 3s are 6, and 6 times 3 is 18. So we're dealing with multiply here. We're dealing with the common ratio. So in this case, A is 2, that's the first term, and we could also call it A1 if we want. And we have the R, and R is 3. So now, what is the general? This is a GP. And what is the general formula for a GP?
AR to the n minus 1.
Thank you so much, Amara. So we have A R to the n minus 1. Yeah. So, A is 2. So part 1, A is 2, R is 3 to the n minus 1. So this here is our formula for this particular sequence, right? And of course, part 2, we have the fifth term, which will be 2 times 3 to the 5 minus 1. And we have the 20th term, which is 2 times 3 to the 20 minus 1. Somebody tell me what the 5th and the 20th term is, please. This one here is 2,324,522,934. And I'm sure you would have seen the little commas on the top of the calculator, right? And this one is what? What's the first one?
I get 162.
Oh, they get 162?
Yeah.
Yes, sir.
All right. Series and summations. This sign is the summation sign. So just like how we'll have a to the n, which, where's this a to the n here? 258 dot dot dot, right? We can have a to the n being 258 dot dot dot, right? And this is just a sequence of numbers, and they're all connected by a rule, right? Well, now we can have the summation, and that is what this sign means, the summation of that sequence, which will now be this. And that is what we're going to talk about now, right? A series is formed by adding the terms of a sequence. So this is a sequence. And when we add the terms of a sequence, this is a series. So the sequence does not have addition signs or multiply signs or whatever. Well, addition signs, because it's summation, right? A finite series contains a finite number of terms. That means that all the terms can be stated. All the terms can be stated. For example, I could have this series, because you notice this have plus signs in the middle, so it's a series. I could have this series 2 to the 1 plus 2 to the 2 plus 2 to the 3 dot dot dot, and you notice I have plus 2 to the 10, no dot 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 after that. So this is my last term. You can see that this is my first. So you can see that I have 10 terms. So this is a finite series. You have a finite number of terms. And so how we do that is we could say the summation of 2 to the r, or 2 to the n, or 2 to the I, or 2 to the p, whatever, right? When r goes from 1 to 10. And this is how we write this. And you see this kind of notation, when we start to use calculus, we're going to see a lot more of that kind of thing. Yeah. So the summation of 2 to the r, right, where from r is equal to 1 to 10, right? So, the series with 10 terms will be the summation of 2 to the r, right, where r goes from 1 to 10. So therefore, the series with n terms will be the summation of the sequence from n is 1 to n, whatever n actually ends up being in the end. So that's for a finite series. For an infinite series, an infinite series contains infinite terms. Dot, dot, dot. We don't know when it's gonna end done. So we now have the series of infinite terms, and we could find the summation of the series of infinite terms by the summation of 2 to the r, where r is 1 to infinity, Right, so this here is the summation of a series of infinite terms. The series is the summation of a sequence of infinite terms, is what I should say. These are some cool rules when it comes to summations. So just like how in logarithms we had rules that we had to learn, these are the series summation rules. For example, if I have the summation of a series AI where I goes from 1 to n, right? And that is being multiplied by a constant, I could pull the constant on the outside. I could find the summation of the series first and then multiply the constant after. Yeah. Second rule, if I have the summation of a constant alone, so, I to n, but it I have no n, it's just literally the summation of the number 2, from I to n or whatever, right? Is literally n multiplied by k. So the summation of the number 2, you could find the summation of your 2 times table here from, if n is 3 2's, well, you'll find what it is here. You wouldn't find the summation of the 2 times table. So I guess the 2 times table is a bad example. But the rule is if you have a constant here and no series, you just nk multiply. If you have 2 sequences in here, whether they adding or subtracting, right, you can literally split up the summation of the 2 sequences. So find the summation of the first one and add it or subtract it to the summation of the second one. And if you have the summation of a sequence plus or minus a constant, it would be the summation of the sequence plus or minus nk. Guess what? Given a series of this, find the value of the summation of the series from 1 to 4 and the 10th term in the sequence. Just now, I'll just gain a message here. Just give me a second. Alright, sorry about that. Okay, so I want the summation of this series from R is 1 to 4, so part A. The summation from R is 1 to 4 of this sequence 3R minus 8. Now I'm literally gonna have to do the groundwork here because it'll be 3, the first term, plus the second term, plus the third term, plus the fourth term equal I'll get minus 2.
Yeah.
Okay. And then part B, the 10th term. Oh, well, look at it right here. You can see the 10th term here is you have a to the r, and a to the r is 3r minus 8. So a to the r, a10, not a to the, a subscript. So a10 is 3, 10, 30 minus 8, which is 22. So the 10th term in this sequence is 22, and the summation of the first 4 terms gives us negative 2, right? An arithmetic series. When we have an arithmetic progression, right? You know how we kind of had to add up all of them? We had to add up, you know, we had like what we had to do here, we had to find each term, you know, and then add it up manually. Well, of course, we don't have to do that anymore. Of course, it have an easier way. So what we have here is the arithmetic sequence, or the AP, is given by this. This is the rule, or this is the formula for our AP. This is the series, and this is the formula for the series. The series is the summation. So if we want to find the sum of the first 4 terms, we could use S of 4 instead of doing it, you know? We could actually use that. Now, the proof of this is pretty interesting. And I actually skipped the proof of it. But the proof of this is pretty interesting. We don't really have to know the proof. We just had to know this formula. Right? So the 5th term of an AP is 1. Check this question. They tell you the 5th term of our AP is 1, and the 10th term is 11. Find the common difference. Find the first term and find the sum of the first 100 terms. So check how we're gonna do this. Given that the 5th term is 1, and the 10th term is 11, I will recall that the terms are given by this formula, a plus n minus 1d. So the 5th term is when n is 5, so 5 minus 1 is 4, so the 5th term is a plus 4d, and well, we know the 5th term is 1, so a plus 4d is equal to 1. And for the 10th term, it'll be a plus 9d, which is equal to 11, because the 10th term is 11. Guess what? We have 2 simultaneous equations to solve. Right? So if we could solve these, and I did not go ahead and solve them simultaneously, yeah? I did not. Because I was like, you know what? All these big people, all you know how to solve. Amara, and you know how to solve simultaneous equations?
Yes, sir.
All right. But just in case anybody, you know, you're too hurting because I didn't solve it, you could just go equation 2 minus equation 1. Right? Elimination. So equation 2 minus equation 1 will be a minus a, is that the a's are gone, and you will get 9d minus 4d. 9d minus 4d is 5d, and 11 minus 1 is 10. So you end up get 5d is equal to 10, d is equal to 2, and then you sub d is equal to 2 in any one of the equations, and you should get a is negative 7. Shanisha, you cool with the simultaneous equation part of it, or do you want me to actually do it out?
Could you do it out, please?
No problem. Well, no problem at all. That's no problem at all. So we have two simultaneous equations here. A plus 4D is equal to 1. And A plus 9D is equal to 11. This is equation 1, and this is equation 2. Right? And I'm just gonna flip them. I'm gonna put the A plus 9D is equal to 11 on top. And I'm gonna put the A plus 4D is equal to 1 underneath. Right? This is equation 2 and this is equation 1. And I'm just gonna go equation 2 minus equation 1. This is the process of elimination. Right? So for the process of elimination, I'm actually noticing that I could eliminate the A's by minusing. So I will eliminate the A's by minusing the equation. So A minus A is A's are gone. 9D minus 4D is 5D, and 11 minus 1 is 10. And so therefore D is equal to 10 on 5, which is 2. You understand that, Shanisha?
Yes, sir.
All right, so this is the elimination method of simultaneous equations. And so therefore, I'm gonna sub D is 2 in any one of the equations. Let me go with equation 1, right? So that means A is gonna be, that's not A plus 4D is 1. A plus 4 times 2 is 1. So A plus 8 is 1. A gonna be 1 minus 8. A is gonna be negative 7. Understand, Shanisha?
Yes, sir.
So you could see here, and you will get questions like this. They gave the first term, they gave the fifth term and the 10th term. And so you use the general rule here in order to get expressions or equations for the fifth term and the 10th term. Those equations you could solve simultaneously in order to find your common difference and your first term, right? So therefore, the sequence itself, we know the first term, which is negative 7 plus n minus 1 times 2. This is the sequence itself. And now they're asking me to find the sum of the first 100 terms. Well, I will use my summation formula. And of course, you just plug in n is 100. You plug in your A is negative 7. And you plug in your common difference, which is 2. Remember, A is negative 7, D is 2, and N is 100. And you'll get the sum of the first 100 terms for this sequence is 9200 for you to try at home. Now, and as I say, next class will be the questions class. That'll be what? Wednesday, yeah. This question and this question are very much like the questions we did before. But check number 2 out. You had to find the sum of the first 100 odd numbers. So what are the odd numbers? 1, 3, 5, 7, ... You know, your first term is 1. Your common difference is 2. And your n will be 100. So you have to find the sum of the first 100 odd numbers. Then, hence, find the sum of the second 100 odd numbers. And I'll just give you a hint. you find the sum of the first 100, then you find, and that'll be the sum from A1 straight up to A100, right? Then you find the sum of the first 200, which is the sum of A1 straight up to A200. And then you minus the sum of the first 100 from the sum of the second, of the first 200. So this is the sum of the full first 100. This is the sum of the full first 200. And then you'll find the sum of the second 100. If you understand what I mean. And these are just hints here. These are just hints. So you're gonna try these questions for homework, 30 seconds to screenshot them. And the next class.
Excuse me, when I say the first 100 odd numbers, I mean like all the 100 numbers it gets in is odd numbers, or like
All-
odd numbers in 100?
No, all of the sum of the first 100 odd numbers. So we're just talking about the sequence of odd numbers. And I want the sum of the first 100. Right?
Oh, okay, so I understand.
Yeah? And of course, you can see number 4 is pretty similar. Find the sum of the first 50 multiples of 3. So your 3 times table. And hence, find the sum of the second 50 multiples of 3. That was the sum of an arithmetic series. Now, we're dealing with the sum of a geometric series. And for a geometric series, a GP, this is the series itself, AR to the n minus 1. But for a geometric series, we actually have 2 sums. And it depends on what that common ratio is. Because when we do the proof for the sum of a GP, we get in this rational function. And the rational function is over R minus 1. So obviously in this case, R would have to be greater than 1. You know, you don't want R to be 1, right? Because obviously you're gonna get undefined. So R would have to be greater than 1 in this case. And if you have a case where R is less than 1, you use this version of the formula instead. Now we will see more of this later on. Later on, you'll kind of understand that R thing a little bit more. For a GP, the 7th term is 320 and the 12th term is 10,240. Find the common ratio, find the first term, and find the sum of the first 12 terms. Well, we do it in a similar way, right? Given that A7 is equal to the 7th term is 320 and the 12th term is 10,240. Recall that we have a general formula for the terms of a geometric progression. And so the 7th term will be AR to the power of 6 because it's n minus 1, right? So AR to the power of 6. So I have AR to the 6 and that is 320. That'll be my equation 1. And I have AR to the 11 and that is 10,240. That is my equation 2. And of course, I have to solve them simultaneously here as well. And I bet you all didn't know that when you're doing simultaneous equations, you could also divide and multiply the equations. Right? Who knew that? So equation 2 divided by equation 1. Remember, the point is to get rid of the a's so that I could just solve the r's. So imagine if I take equation 2, which is AR11, and divide it by equation 1, which is AR to the 6. I have to do the same thing on the other side, which will be 10,240 divided by 320. Notice the a's will cancel. 6 of these will cancel with 6 of these. So I'll just have 5 of them remaining. And then on this side, I believe when you divide this and this, you do get 32. So now we can actually solve, right? And yeah, we could go the 5th root of 32, or we could also recognize that 32 is 2 to the power of 5. And so if the 2 of them is 5, well then r will have to be 2. And now I could sub r is 2 in any one of the equations. So let me go with equation 1. Right? A times 2 to the power of 6 is 320. So A will be 320 divided by 2 to the power of 6, which is 320 divided by 64, which is 5. So now we have a GP, a to the n is equal to 5 times 2 to the power of n minus 1. Where a, the first term is 5, and my common ratio r is 2. And of course, we need to find the sum of the first 12 terms. So then we use, r is greater than 1. So we could use the one where r is first. The formula where r is before the 1. And of course, it's just a matter of plugging in your values here. The sum of the first 12 terms. So in this case, a will be 5, r is 2, and n will be 12.